Hey guys, this is Jake. So today we're going to be making an API. An API is something that runs underneath the hood of an application. So according to a video by MuleSoft Videos, an API is a messenger that takes in a request, tells the system what you want to do, and then it returns a response. So it's kind of like a waiter at a restaurant. So take a weather service, for instance. A weather service API would allow the user to supply a zip code, and then it would return a high and a low temperature. So this specific API that we're making is kind of taken off of Hatchway's assessment. So if you're not familiar with Hatchways, it is a job interview project assessment site. So I don't know how copyright works exactly, but I thought I should include this just in case. And I do want to say that this is a little bit different from the Hatchways assessment in that this uses MySQL, whereas the Hatchways assessment does not. So without further ado, let's look at what we need to download in order to make this API. First thing that you'll need is Java 17, and I'll include a link for these in the description, but choose the correct installer here. And then once you install that, go to your terminal if you're using Mac, and inside of your bash profile, instead of bash profile, there should be, you should add an export statement for Java home /user/libx/Java home. And if you're using Mac, you would go to the system environment variables and add a new variable called Java home and include the location of your JDK there. So once you've installed that, you're going to also install Maven. You're going to install Eclipse IDE for Java developers, Java Spring Boot, Postman, and then MySQL with MySQL Workbench. And then optionally, you're going to add Visual Studio Code, which I'll be using here to actually write the code. So once you have everything installed, we're going to go to Visual Studio Code if you're using that. If you're not, if you're just using Eclipse, that's okay as well. But if you're using Visual Studio Code, you're going to go to Extensions and look for Spring Boot Extension Pack, and then install it. Once you have that installed, you're going to be able to create a Maven project by doing Command-Shift-P, Spring Initializer, create Maven project. And if you're not using Visual Studio Code, you're going to use the website start.spring.io and follow these same steps. So you're going to choose the Spring Boot version, then Java, com.example as your group ID, recipe as your artifact jar, and then let's do Java's version 17. And then you're going to include 3 dependencies. You're going to do Spring Web, you're going to do MySQL Driver, and then you're going to do Spring Data JPA, and then click Enter to include all of them. Now it's going to ask you for a place to generate your project. So I'm going to go to my main folder, Jake Schramm, which is my name, and then delete this. I'm going to create a new folder called Recipe and generate into this folder. So once that's created, it will open up in Visual Studio Code automatically. But if you're using the website, it'll have a zip file that you open as well. And you can extract into the folder that you want it in. And so then you can open it in Eclipse as well, which is what we'll do. You're actually going to go to Import Maven, and you want to do existing Maven projects. And then choose the location that you just downloaded or generated your file in. Once you have your project imported in Eclipse, we're going to create 4 packages. So go to source main/java, new package. We're going to do com.example.recipe.repository. And then we're going to do com.example.recipe.service. com.example.recipe.controller. And then we're going to create a model class as well, or a model package. So once you have these 4, great. And so the API, the kind of API that we're creating is called a REST API. And what that just means is that it contains several constraints that make it REST. A few of those include things like having a decoupled client and server app where the client and server are completely independent of one another, and statelessness where no client info is stored in between requests. There's several other constraints, but we won't get into those. But what this API will do is it will take in a request and it will get info based on that request. So if we do a request here for /recipes at the end of localhost and port number, we will get recipe names and then the list of recipe names. So that's info that we retrieved. And a GET request is often used for retrieving resources. There's different kinds here, but that's what GET does. And so this is in our controller class, but I have code written where it is at request mapping and has the value /recipes, and it has the method GET. So I have coded this route to return something. And that's why we see something here. So let's start implementing the API functionalities. So the ability to get, update, and delete recipes. First, we'll need a model to store the recipe objects in. So to do this, go to our model repository, create a new file. We're going to do recipe.java. Okay. And so now that we have this, let's add some fields to it. So private long ID, private string ingredients, and private string instructions. And so these would be our fields, and they'll correspond to a database table, which we'll get to in a second. So in order to correspond to a database table, we need entity, we need table, and then the name of the table, which we will call recipe. That'll be the name of our MySQL table. And so this is where we'll also include some things in application.properties in order to connect to MySQL. And I'll include these in the description, but there's basically a list of things that you need to include. And one of them is the URL, like spring.datasource.url. And that'll include jdbc, but it'll also include the schema name at the very end and the port number of MySQL. And another thing we want to include in here is our server port number that we run on, like the whole application. So let's do 8123. Normally it's 8080, but we'll do this for this case. So once you have application.properties, let's also, while we're here, configure Eclipse so that it runs properly. So right-click your project, do run as, do Maven build, and then for the goal, we'll do Spring Boot run, and then environment variables add, we'll do spring.datasource.username, and then you want to do your MySQL root username, and then spring.datasource.password, and then whatever your MySQL password is. For mine, it's newPass, and then click apply. So this will be important in order to run your project later on. So now let's go back to our model in Visual Studio Code. And oh yeah, we want to import JavaX persistence for the table. But for the ID, let's include @ID, and then generated value, and then you'll do strategy, equals generation type dot identity. And what this will do is that it'll go to the auto configured or the auto incremented column ID, and it will automatically generate IDs for this, for your database. So let's go to MySQL. And if you haven't already, create a database called test1. That'll be your schema name because it's the schema that we use in application.properties. And then change that database. And then we'll create a table called recipe. And it will include these fields that we included in our model. And one more thing while we're at it, this is for Eclipse purposes, since we're just configuring things here. In your project properties, we want to make sure that our Java compiler is the right one. So go to Properties, go to Java compiler. So I've selected 17. Make sure that yours is that too. And you also want to make sure you're installed JREs. If you have a message down here that talks about install JREs, make sure that it is the 17 one. And then also change it in the execution environment, which will also give you an option if it says anything here as well. So that just makes sure that Eclipse will work properly when we run the program. So now that we have created our MySQL table and we've configured these things, let's finish our model class. So go inside your model class, and we're gonna make these columns. So at column, name equals ID, and then at column, name equals ingredients. And let's actually add one more field that I forgot to add, string recipe name. Because see, in our table, we also have recipe name. So at column, name equals recipe name, and then at column, name equals instructions. And then we'll import this. So then all you need is getters and setters. I will generate these using a program that I have, like it's an extension for Java, but you can write them out if you want to. So now that we have our model done, let's create our repository class. And by the way, if you want the extension, it's called Java Code Generators in Visual Studio Code. So anyways, let's go to repository and name this recipe repository.java. And this will be very simple to make because it's just an interface. So we'll do public interface recipe repository extends JPA repository, and then the first kind of argument we'll have here is recipe, and then comma long. And so recipe will be the type of our model, and then long will be the type of the ID that we're using in our model. And so this will allow us to have access to repository methods in our service class, which we will make now. So make a new class here in your service repository called recipe service. And this will contain basically methods for interacting with the database. So put service at the top. And then because of repository methods, these methods will be much easier to implement. So let's first implement a Getrecipes method. And inside of our service class, by the way, we want to have something, we want to write this as well. It'll be recipe repository, rest repository. And so make sure that you import the top this as well. And so now we can finish implementing our method. All you do is call the repository method, find all. And this will get all of your recipes from the database. So let's do return. So once you have your GetRecipes method, then we move on to create recipe. So public recipe, create recipe. And this method will return the recipe that is created. And normally that would just involve calling the repository save method, but we want to add the functionality of not adding a recipe if there's already a name equal to it in the database. So we are going to first add that functionality to check if the recipe already exists. So let's do list recipe list equals get recipes, and then for int I equals 0, I is less than list size, I plus plus. We're going to check if the name is equal. So if list.getI.getRecipeName equals recipe name, then we will, and recipe name, let's actually add it here. So recipe name equals the name of the recipe that you pass in. So in this case, return null, because that means that you found a match, therefore you don't want to add a new recipe with that name because it already exists in the database. So return null. And this will help us in our controller where we call this method, because we know that if it returns null, then it means that that case happened. Otherwise, outside of the for loop, let's return recipe repository.save, and this will automatically add it to the database. So that is your create recipe method. Now that that's done, let's do another kind of method that will be used here. Let's do update recipe. So this will be very similar, except it will update the recipe with an existing ID. And before we do this, let's actually create a helper method. And I don't know if you could see that. Now that I'm scrolling down, you can. So let's create a helper method first before we implement this. The helper method will be get ID from name and so this will be pretty self-explanatory, but you want to be able to get the ID from the name because we need a recipe with an existing ID here, and we want to get that by ID. So first we're going to assume that if a recipe with that name does not exist, then we want this to return -1. Otherwise, let's search the recipe list. So we have the method getRecipes that we can call. And then for integer I equals 0. If list.getI.getRecipeName equals recipe name, then we're going to set the ID equal to that recipe's ID and return it. Otherwise, if it wasn't found, then return -1. And so now that we have this method, we can implement the update recipe method. So we're going to do long ID equals get ID from name recipe dot. Actually, instead of recipe here, let's do string recipe name, because and then we're going to add 2 more parameters. We're going to add ingredients and instructions. And so the goal is to update the recipe with this name and give it this new ingredients and instructions. So get ID from name, recipe name, and if ID is not equal to -1, then we're going to create a recipe, and we're going to find the recipe with the ID that is here. And we're going to set the ingredients and instructions of that recipe. Finally, return recipe repository.save. So this will update because it knows the ID of this recipe that's returning, and therefore save function will actually cause an update rather than a create. And so that's if the ID is not equal to -1. In other words, if the recipe exists. If it doesn't exist, then we want to return null. And this will make it easy, again, for the caller, because we know that if it returns null, then the recipe did not exist. So now we have our create, update, and get. Now all we need from the credit operations is delete. So let's implement delete, and this is going to be very easy because there's a repository function that allows you to delete by ID. And we have a way of getting the ID by name now. So let's do public void delete recipe, string recipe name, and then all you do is recipe repository.delete by ID, and there you have it. Those are your 4 CRUD operations. Let's add an additional method. Right now we have get recipes. Let's try get recipe names. So this will allow you to, instead of getting all the recipes from the database, it will get only the names of those recipes. So it will be very similar. It will call this method, but we're going to basically make a list of recipes. Get all the recipes in them, and then we're going to create a new list. Let's call this return list because it'll be the one that we return. And it's going to be started off as empty. And so basically for every recipe in our get recipes list, we want to add the name of that recipe. So r.get recipe name to the other list. And then we're going to return list. And so this will successfully get all of your names. We're going to add one more method. This will be the last method of this class, this service class. And it will be one that gets the number of ingredients and number of instructions of a recipe object. So to do this, we're actually going to return it in a specific format of JSON format. And so we want to create a JSON object to return these elements in. So let's do public JSON object. And actually, in order to use the word JSON object, we're going to need to we're actually going to need to include a new dependency in our POM XML. So let's do that in a second. Let's make the method definition. Number of ingredients and steps, and we're actually going to get the number of ingredients and steps of a recipe name. So in order to use JSON object, you need to include this dependency in your POM XML. It's going to have group ID organization.json, artifact ID JSON, and then the version is 20220320. I will include a link in the description that will give you the ability to look at other versions in case this one doesn't work. But this is the one that I'm using in this video. So now that you've included that, and once it adds to your class path, if you wait for a little bit, then you will need to import in this class organization.json.json object, and then you'll be able to use the JSON object object. And so now we can implement this method. So let's first create a new JSON object. And our goal here is to basically create a details object inside of a larger object that will contain the number of ingredients and the number of, and the number of instructions. Get ID from name, there we go. So once we have the ID, we're going to check again if this exists. If it doesn't, return null. Otherwise, recipe r equals recipe repository dot find by ID. ID get, and then JSON object, the inner object. This will be the object that is labeled details that we're looking for. And so for this inner object, we're going to add two attributes. Remember, we want the number of ingredients and the number of instructions. So in order to get these, we actually have to pass in the comma separated list and turn it into an array because we want to get the number of elements in that comma separated list. So to do that, we're going to do r.getIngredients.split on the comma .length. And that will turn our ingredients into an array, and then we'll get the length of that array. So let's do the same for instructions. .split .length. And then we're going to add this inner object to the outer object so that it returns the correct format that we're looking for in our result. So put details inner object, which contains the number of ingredients and instructions, and then we're going to return the JSON object. So now that we have all of our service methods, let's implement our controller. Each controller method will represent a mapping or the URL that we will enter for API request, and it will give a response. So this one is already written, and it's a GET request. And so at request mapping, notice two things here. We have our value, which is /recipes. This is the route that will be included at the end of localhost : port number in our request. And then you have a method, which is GET, and this can be post or delete, but in this case, it's GET. And so you have those two things. And so what this method will do is it will allow us to make a GET request to localhost : port number /recipes, and it will return a list of the recipes here as a response. So the response is of type response entity. That's what we want to return. And a response entity is a container for a status and a body. So the status here that we're returning is HTTP status OK, and you see that here in a successful response. You can also include other statuses like bad request, which I have a code of 400, and that'll indicate that maybe there was an error in the syntax of the request. And then it also has the body, which is basically our response message. And in this case, that's a list of the recipes. And so notice that is of type map. It's because we want it to be in like a nice key value format, like with the recipe names : the list. But you could also include an error message as your response. Say if you wanted to do HTTP status bad request and then you include an error message in your body, that would be valid. So for this GET method, feel free to copy this code. And notice one more thing. In the port number here, it's 8123. That's the same port number that we included in our application.properties file in the server.port field. So make sure that those match. Now, what if you wanted to include other API methods? So like a post request in order to create a recipe. Well, for that, it's a similar syntax. I'm actually going to copy and paste. And make sure that you've imported these things as well, and you have these annotations. Those are important in order for this to work. So for this post request, we're going to use something called a request body. So similar to how responses have a body, like this, the list of recipe names, requests can also have a body. We're going to use these fields in the request body to create a new recipe. Wait a minute, I thought ingredients and instructions were of type string. They are, but in here they're type list. So we're going to convert from a list to string in our controller method. So we're going to get these values from the request body. So first we're going to create a new recipe. And then for the ingredients here, we're going to convert from list to type string. And we're going to do that using spring.join. And it's going to start off as an array list type string, and then we're going to do recipe.get, and we're going to get the ingredients field from the map in our request body. And then we're going to do the same for instructions. String.join. So this is, again, it's creating a string out of the list. A comma separated string, so that we can store it in the database, because databases don't store lists, they store strings. So set recipe name. This we can just do recipe.get recipe name because it's already a string in the request body. And we want to do .toString. And so now we can call our create recipe method that we created earlier. Equals recipe service dot create recipe r, and remember this returns null if the recipe already existed. So we're going to have the null case, and in that case we're going to print a error message. The error message here is going to be a type map, and the reason why is because of formatting. Like, it looks nice to have a error : error message format. So that's the only reason we're doing this here. So error statement dot put error recipe already exists, and then we're going to return in the null case a response entity with a status of bad request. So status, and the body will be the error message. Otherwise, if it did work, then we're going to return a successful response entity. With an empty body. So that's your post request. Now we're able to make a post request with a new recipe to create in our request body, and it will store it in the database. So now let's do the controller method for getting a number of ingredients and number of instructions from a recipe. So it's going to start off kind of similar, except this time we're going to have something called a path variable. So you see it says /recipe/details/recipe name in curly brackets. The curly bracket is a path variable. We're going to import this. And so what this allows us to do is to use what the user enters in here as a variable. And notice how the value equals is the same name. So we're going to be able to use this name, and then we're going to do for the number of instructions, we're going to do JSON. Remember, this returns a JSON object. JSON object equals recipe service dot get number of ingredients and number of steps. And then as a parameter, we're going to have the name path variable. And remember to import this. And remember, this method returns null if the recipe does not exist. So if JSON object equals null, then it's going to create an error message. And the error message is a map again. going to return response entity with the error message. Otherwise, if it does exist, it's going to return response entity. It's going to have an OK status. And the body will be the JSON object turned into a string. So it'll return what this method returns, which is, remember, the details JSON object. So that is our number of ingredients and instructions method. Now let's move on to update. So this is going to be similar to create, but it will update an existing recipe. If you try to call it on a recipe that doesn't exist, then it'll have an error message. So we're going to do @request mapping value equals /recipes. And the method this time is going to be put, because put is often used for updating. We do public response entity and we're going to have a request body here because we want to update it with what is in the request body. And that'll be, actually we're going to have, first we're going to have the recipe name and then the request body. This is just request method. Okay, and so now we are going to do, we're going to call the update method inside. So spr equals update recipe with recipe name, and then this is where we will call string join, because we're gonna, if we're getting from the request body, again, we're gonna convert from list to string. So we're gonna do string.join on a comma, and then it's gonna start off as a race string. And then it'll do recipe, or actually map.get ingredients. And then we're going to do the same for instructions. So string.join array is a string map.get instructions. And so this will be the second parameter. Hold on. Okay, and so that'll have R. And so R, when we call update recipe, it will be null if the recipe doesn't exist. So if R equals null, then we're gonna simply have the error message. So let's copy and paste from up here. Otherwise, it'll return successful. So response entity dot status with a body of empty. Okay, now let's implement our last controller method, which will be delete. So delete will be kind of like the others, except it'll have recipe name as a path variable, and that allows us to use this, whatever the user enters in, as a variable, and we want to delete by name. So this will be simple to implement. We just do recipe service dot delete recipe, and then delete the name that is passed in, and then return response entity dot status http status dot ok body, and the body will be empty. So I believe these errors are just there. Yeah. So this will be our delete method. Now that we have everything implemented in our controller, let's start testing. So you can test manually, right? Like you can go and do post, and we have something here. Let's do scrambled eggs 9 as the recipe we want to create. We test our post request, create something, and we can test if it really created something by calling get. Actually, I changed it to 8124 rather than 8123 because my port wasn't working earlier. So I'm changing this. And now if we go into our list, it says scrambled eggs 9. So it successfully added it to the database. So how do we test it without Postman? How do we use JUnit tests to test the proper responses? Well, let's go to our test folder. And we have, this is where we will place our tests. So we don't have anything yet, but before we do testing, let's add some dependencies to our POM.xml. I'll include these in the description, but you need 2 of them. You need HTTP client and you need JUnit. Once you add those, go back to your test folder or your test file, and then we're going to implement our first test. So first we need to make a GET request, HTTP GET request, and this will be done using HTTP client. Create build, and then you're going to do HTTP GET equals, well, let's call it request, equals HTTP GET, and then you'll include the URL that you would normally put in Postman. So HTTP localhost 8124. You might be using 8123 if you're still using the same port, /recipes. And let's see, HTTP GET, yeah. And so I've imported a few things up here to help me actually use these. And this will be a new HTTP GET. So then we're going to do organization.apache.http response. And that'll equal client.execute request. So the response will be what you get from executing the request. And we do HTTP entity equals response.getEntity. And then finally, string content will equal response dot, or I'm sorry, it will equal entity utilities dot toString entity. So the content will be basically the body of the response that we want. So by executing this request. So once we have that, we can use the content and turn it into a JSON object. We want to turn it into a JSON object because we want to test for specific values to see if the response is contained, or see if the response contains those values. So for example, JSON object equals new JSON object content. We want to see if the recipe names array exists in this object that is returned. So we're going to do assert not null JSON object get JSON array recipe names. And if this is not null, then we know that it was a successful request, because a successful request looks like this. It contains recipe names. So this is testing for a successful response. And another thing we want to test is the status. So assert equals status response get status line dot get status code, and test if that equals 200, because that'll be the OK response. So this is your first test. It'll test for successful recipes call. We want to implement another test, and this will test for the details API call. So we need to do /details, like /recipes/details, then / recipe name. We want to see if that gives you a proper response. So we're going to do test details, and it'll look very similar to this test up here. Actually, we're going to copy and paste because we want to make a GET request first to get all the recipes, and then we need a valid recipe name in order to call the details one. So in order to get a valid recipe name, we're going to get the first index from the list and get that recipe and get its name. So let's first do JSON object. So make a JSON object out of the content, and then string recipe name equals JSON result object dot get JSON array recipe names dot get 0 to string. So this will be the recipe name that we can use in our details call now. And so now let's do everything that we just did except change the call to recipe/details/ plus recipe name. And so this is what we're testing now. And let's make all these 2 in order to get rid of duplicates. So add a 2 to the end of each of these little parts. Content 2. And now content 2 will be the response of this call. So we're going to make a JSON object out of that and see if details exists in it, the details JSON object. Because a proper response looks like this. It'll look like this, and it will basically contain the object called details. So we want to test to see if that exists here. So let's do assert not null, and then the second thing we want to test is the status. So assert equals, we want to do response to dot get status line get status code 200. So once that works, you can test these tests to see if they work. So go to Eclipse, and I actually had an error earlier. Hold on, let's save this. In order for if your Eclipse doesn't run in this instance, there will be some extra steps you need to do, but let's run this. First, you want to make sure your actual application is running before you run your tests. Okay, port 814 is already in use, so let's change the port number real quick. And then let's go to our tests. And change this to that port number that we just changed it to, and all of our URLs. Okay, go back and test it again. Now we can run tests as JUnit test. And we got 2 successes. So we know that our application is working for those specific methods that we tested. And if you're not able to run here, like if you're getting a class not found error or something like that, there's actually a way to fix that. You want to go to Java build path. So you do right click, build path, configure build path, and then you'll go to Java build path and source and add folder. And on your add folder, you want to include model and repository. Once you do that, click apply and close, and it'll add it to your path. And then what you do is you copy and paste the code that you had originally for repository and recipe and put it in put a recipe and repository class inside of those folders. And what it's going to do at the top of those files, it's going to have a package statement. It's going to ask you to change, like basically move it to the new package. Say yes for both of them, for both repository and recipe. And once you do that, it'll get rid of the errors. And so once you have that done, like once we've written our tests and everything, that's pretty much everything that we have here. So there you have it. We have a working API. Normally you'd include more tests for this, but we've just included 2. It's a similar idea for the others where you just make a request and test to see the response. But that's it. Thank you for watching, and I hope you enjoyed this video.